This webinar is about potentiometers, or known as variable resistors. We're going to talk about what a potentiometer is, we're going to assemble it to a breadboard, and then we're going to do some coding. This will be a rather short webinar. A potentiometer is a resistor that you can adjust. We use potentiometers to control the brightness of an LED, control servo, adjust the volume of a music player. What this relates to is potentiometers contain a resistive element inside the two stationary terminals. Think A and B, and then there's a resistive element that connects between A and B, and we have a wiper of resistance. All right? And what's really works is on this. If you take a wire and hook it up to a 9-volt battery, positive and grounds on a 9-volt battery, and you took two of those ground wires and you put them on your skin, if they're farther away apart, you won't feel it. But if you bring both the positive and ground closer together on your skin, you will feel a slight shock. That is, the closer you get, there's less resistance in this case. And so we have resistive material, so the more you travel through that resistance material, the greater resistance. Vice versa, if you travel through less of the resistive material, you're going to have less resistance. Let's set up our hardware. You're going to need a potentiometer, a few LEDs, 330 resistor, not that 10K, make sure it's the 330. So we have a red board. We have a light emitting diode, we have a 330 ohm resistor, we have a potentiometer, 5 volts, and we're connecting off to our A0, our analog. This is a classic case we're going to be reading analog off this. So it should look for something like this, and I'll give you a few seconds to build this. Go ahead and pause the video if you need to. Let's look at programming this. Alright, first line of our code is make a variable called sensor pin. We're going to also set it to 0. LED pin 13, that's going to be the pin for our LED. Sensor value equals 0. This is where we store the value from A0. So when we use our sensor pin, we need to store that. We're going to store it in the sensor value. Void setup. Pin mode, LED pin, comma output, declares the LED pin as an output. Remember, the LED pin is an out. Pin mode, sensor pin input says, hey, sensor pin, make that an input. All right? And in this case, it's 0. You could also have had, so you could have sensor pin up there. You could have also written, and we've been totally fine to say, pin mode, parentheses, capital A, 0, comma, capital input, INPUT, parentheses, semicolon. Now, that's the void setup. Let's look at our void loop. Alright, what we're going to be doing on this program is we are going to set the duration of the LED blink by changing the potentiometer. Sensor value equals analog read sensor pin. So it's reading off, and it's analog, and it's pin 0. Let's go back up here and look at this real quick. So you're reading off this pin right here, 0, which is analog. And what you're reading is off the potentiometer right here. So, analog read sensor pin, which in the case is 0. Digital write LED pin high, turns the LED on. Delay is the sensor value as well. So you've turned on you read off your sensor pin, you set the LED pin on the high, and then your delay is the value of your sensor pin. Then, after the delay is over, you set LED pin to low, and you set that to the sensor value. Go ahead and try it. After you fully extend and run the code, we're going to try some things. We're going to set a threshold, and we're going to do execute LED fading. Alright. In this case, if sensor pin 0, we can go ahead, in fact, save what you just have done, and now give this a new name and save the second program looks just like you did in the past. So you have integer sensor pin 0, you have LED pin 13, sensor value 0. Void setup, LED pin output, pin mode sensor pin input. Again, that's that AO as an input. Now what this is different, this void loop is different than what we just did. Threshold we're going to set to 512. Now it could be a range. Alright? Alright? So it's 512 because the sensor can read off that potentiometer up to 1023 actually. So if sensor value equals analog read sensor pin, if, alright, so we're taking the sensor pin off the analog read, we're storing it to sensor value. If sensor value is greater than the threshold, we just said the threshold was 512, then turn on the pin high. Else, turn it low. So this is going to find the minimum value, right? Now once you go above this, the LED is going to go on. Otherwise, it's going to be off. And half of the potentiometer goes up to 1023, so 512 is about the halfway point. Go ahead, save this as a new. You can your name, threshold, whatever. Save it from the other program you just did. So you can go back and look at this. Now, what we could do, just to add a little bit more spice to this so it's a little bit easier for you to understand, add sensor begin, parentheses, 9600 parentheses, semicolon, and that's why slash added it said. So I want you to see we've added that line, and then we're going to add down here. So threshold's 512, sensor value, analog read, sensor pin. Then we do serial print line sensor value, slash s added. If analog read sensor pin is greater than threshold, again turn it high, otherwise turn the pin low. If you turn on your sensor monitor now, use your potentiometer, turn it back and forth, and you're going to see the values of your potentiometer. And you're going to see when they're greater than 512, that's when your light's on. When not, it goes dark. Again, save this as a new name of a program and make sure it works. I'll give you a few moments to do this, and you can always stop the recording and pause it. Alright, in this last one we're going to do with the potentiometer, we are going to look at it, and now we're going to set the brightness of the LED pin. But to do that, we're going to need to use analog read and analog write. Analog write. Our pin needs to be an analog or PWM pin. For example, 9. So we're changing LED pin to 9. So the nice thing about using a variable here, we only have to change one thing, that's 9. Again, you should have named this something else, you know, dimming LED lights, whatever you want to call it. Then void setup, LED pin output, pin mode is the sensor pin input. Again, what we've been doing. Void live is different though. We're going to create a variable, it's going to be an integer, whole number, equals analog read of sensor pin 0. Remember we just said there's a value. And we're dividing it by 4. We have to because analog write only goes 0 to 255, where the analog read is going to get a value somewhere because of the potentiometer somewhere between 0 and 1023. So that's why we do that /4. Analog write, LED print, that value. So what it's doing is, since it's an analog, it's saying I want to take that pin and I'm going to set it to the value. Alright? And we got value from the analog read of sensor pin divided by 4. So that's a great way. You should be able to do 3 things now. Use your potentiometer to delay how long the blink's going to be. To use it to set when the LED light's going to go on or off as you turn the potentiometer. And finally, make it dimmer for your LED. Alright? Thank you very much.